Good morning, everybody. Thank you for joining our webinar today, Anchoring Solutions for Mass Timber. Um, on this webinar Wednesday by Rothoblast. My name is Chris Chikeji, and I am the marketing account here in the United States and Canada for Rothoblast. I just want to remind you, as always, if you do have any questions, we'll be answering those towards the end of the presentation. If you're on a computer, on the top bar, you should see a button for the Q&A section where you can type your questions, or if you're on a phone in the bottom right-hand corner, there's 3 dots that'll open up the same type of menu, and you'll find the button to access the Q&A. And send any comments or questions throughout the presentation. So without further ado, I'm going to pass it on over to Nilu, who will be leading our presentation today.
Hello, everyone, and welcome to our webinar regarding anchoring solutions for mass timber. My name is Nilu Hoshbach. I'm a technical consultant working at Rothoblast, and I'm based in Pennsylvania. A little bit about our company. As you see here, we are providing solutions for mass timber construction all around the world. We have 25 plus warehouses serving more than 100 countries with our team of engineers and sales force. Specifically in North America, we have more than 1,000 clients and serving 60 states and provinces. In Canada and US with 2 warehouses. And if you want to learn more about the major project we touched in North America, you can go to Wood Innovation Network and search our name there. All right, today we're talking about anchoring solutions. Hold downs, brackets, plates, post spaces, all means of connecting mass timber structures to the ground. And here's the outline for today. It will be a little bit, we talk about why proper anchoring is crucial, and then talk about 5 types of anchors for mass timber, and a little bit talking about Rothoblast hold downs, brackets, and post spaces, and some of our innovative ground connection systems. We have a range of products for connecting CLT walls to the ground. We have angle brackets, hold downs like WKR, WHT plates, WHT and WHT plates, and some of our innovative ones like ALUSTART. And we also have some advanced innovative solutions like Uplift and Titan that I will Titan Dive that I will discuss in the end of the webinar. But first start with design for horizontal forces. So what you see is a basic concept, not only in mass timber construction, but in construction in general. When a structure is like subjected to horizontal forces, like wind and earthquake, there are different ways how building could fail, and we're not going to discuss how to brace the building. Today, our focus will be on the connection to the floor. So for connecting to the foundation, connecting to foundation, what you see is the horizontal forces will be translated into moment, which in the end, it will be shear forces on the floor or tensile forces. We receive tensile forces with hold downs and shear loads, usually with brackets. This picture shows a standard approach that has been around for a while, and it's developed for light frame structures. That you just used a tensile angle brackets specifically for tension and shear brackets for and angle brackets for shear forces, for resisting shear forces. And this is a legacy system adapted from light frame buildings, and it works in theory. But in practice, what you see is, for example, here, this is some experimental results from Gabrick et al. As you see, these angle brackets not only withstand shear, but also like almost withstand tensile forces. Or for even for the hold down, for tensile hold downs, they just take a little bit of shear, as you see here. And the thing is, that's the standard system, as I mentioned, adopted for light frame buildings. And the standard connectors are not optimized to withstand high loads of CLT massive elements. And this can lead to unexpected failure of connectors. Here are some of the examples of failures of, for example, net cross-section failure of the plate. Here you see pull through of the fastener. This one is a withdrawal of nails, rotational failure, and finally buckling. That's why we moved to more innovative approaches in which angle brackets are optimized to take both shear and tensile forces. And we've conducted several testing campaigns to develop new products. I'll discuss those products shortly. But before, I'd like to provide a bit of context regarding the design of hold downs. And as you might remember from my previous webinar, or you might know that a connection system is we look at it as a chain made of ductile and brittle component. And we discussed the importance of ductility layer before. I just want to emphasize we always want the screw in timber fail first and be the ductile part of this chain, because if the steel or concrete fails, we will have like the whole chain will fall apart. It doesn't maintain the integrity of the connection. And you see here, for example, this is the breakage of the steel side. This is like breakage here and in concrete. So this is the ideal for us, because if the screw yields, the connection doesn't fall apart. This is our basis of the design and testing in rotables. And speaking of testing, this is just one of the examples. This one I'm sharing the results for example, here for our WKR hold downs, and here as you see the failure happens in the timber side, and it's more of a ductile behavior. All right, so what you see here is like the classic brackets versus the modern ones, and small angle brackets have always been around, like originated for just to restrain loads in light framing. And these modern brackets developed, these ones developed by Rotoblas about 15 years ago, and the performance was improved without like getting taller. For example, for shear angle bracket, like adding washers as a reinforcement, changing the screw, the nail pattern, adding like bigger screws, and it's still ongoing research that boosting capacity for mass timber application. And we ran several test campaigns collaborating with universities to test the products itself, both locally and like in as you see here, like as a structural element, and to find a relationship between local and global ductility, which is used for engineers use for seismic design. This one is specifically we tested hold downs, like some sort of tradition. It's a light frame structure with like traditional way of connecting to the ground. We compare it with using only brackets, using brackets and hold downs for CLT shear wall, and also we tested only for Tighten only angle brackets on CLT shear. And as you see the results here, this blue line belongs to angle bracket, Tighten angle brackets only used on CLT wall. That gives us a higher capacity compared to the standard application of hold downs and angle brackets. And also the lowest value comes to the light frame with a like traditional way of connecting to the floor. All right, now let's discuss a little bit. In this part, we discuss a little bit about the concrete anchors, because anchoring to concrete requires precise selection of mechanical or chemical, and we explored a range of solution available from Rothelass. We'll talk about fixing, support material, installation, and failure mode, and some of our products. Here, as you see here, fixing to concrete can be classified into two main categories. One is pre-installed fixing, which involves putting anchors during the concrete casting, and this is ideal for projects that are just usually for the project that requires high load bearing capacity and some sort of precise positioning. And then we have post-install fixing that, for example, our angle brackets can be used this way also, or as you see here, we have threaded rod with Z-epox that they drill the hole in the concrete layer and use Z-epox to secure the rod. And this approach is like more flexible. Is good for modifications after pouring concrete, or like suitable for some sort of on-site adjustment, retrofit. The other thing is for post-installed combinations. There are different type of fasteners available. One is the fixing, fixing by shape, which is you anchoring through the concrete by some sort of these SKR bolts, and they cut the concrete and how it's like grab onto the concrete this way. But we have the other option, which is like expansion. It works through the friction, and the expansion in the concrete creates a friction, and that's the way that the fixing the anchor holds onto concrete. And the last one is just using chemical anchors. Like they bond the anchor to the concrete with like some sort of epoxy. All right, support material is really important for the choice of anchoring systems. And common substrate could be stone, which is very, it's dense but it's uneven. Then we have concrete, which offers more uniform and better load-bearing capacities. Then we have brick. It is reliable, but yeah, it's some sort of reliable. But the hollow brick, this one needs specialized anchors because of the voids, and maybe sometimes you need to do custom-made anchors for this. And here's a summary table that which anchors you can use with which support material. As you see here for concrete, you can use mechanical anchors and epoxy, no problem. And for the full break, it's suitable for mechanical and chemical anchors, but for only the screw anchors won't work here. And for the hollow break, as you see, it needs a specialized way of anchoring, or the best way is just to use a sleeve and the epox, or make something specified to this hollow break. Regarding anchor installation mode, um, there are through and non-through. For through installation mode, the fixture and the substrate are like you do the anchoring in a single step. This is faster and easier. But the thing is, if you wanna, you don't wanna have any like a scratch on the fixing. Maybe you want to do the non-through, which you install the anchor first in the substrate and then add the fixing. Um, um, these are some of the important parameters for anchor installation, that following them helps making sure that the anchor is safe and efficient. Things like the thickness of the fixture, and the diameter of the hole, the depth of the insertion, like minimum thickness of the substrate. And these are important to make sure the anchor won't fail. And this is some sort of different types of failure mechanism that can happen due to tensile stresses or shear stresses. Tensile stresses can break the steel itself if you don't have enough embedment depth, or not enough good bonding between the concrete and the concrete anchor. You may get pull out. Concrete cone failure can happen if you don't have enough. The concrete itself can resist the tensile, and if you don't have good enough distances on the edges, splitting may happen. Also, regarding for shear stresses, also it could happen to the material, the anchor material, steel material itself, or if you don't have enough depth, you may end up with this type of failure. And if you're so close to the edge, you may end up with edge failure. There is one important thing that I have to mention, is the proper cleaning of the drilled hole. That affects the resistance, the connection. You can clean the hole with just regular brushes. The brushes for that is meant for this. And the other thing is, you can use some sort of pumps, vacuum systems, and there is also another way, using this hollow drill bit that can simultaneously, you can drill and vacuum. And to show you the importance of the proper hole cleaning, they install the screws here, as you see in the picture. And they installed it in a clean hole and not clean hole, and then they did an extraction test, and it shows that the hole that was not cleaned had 40% less resistance. We have also chemical anchors, that there are two important parameters that usually you can find it in the back of the product itself, and it's called workability time and curing time. Also, the temperature that you apply the chemical anchor is important, and workability time is the time that anchor forms a paste. But curing time is the time that you have to let it sit before apply loading to the connection. And this time varies by the composition of the anchor, whether it's polyester, vinyl hybrid, or epoxy. Rotoblast offers a wide range of chemical anchors. And here you see in the picture that we have like vinyl hybrid, and epoxy. And they have significant differences in the curing time, workability time, and as you see here, the tensile strength is different, but either you use it on a cracked concrete, uncracked concrete, or for seismic purposes. In our catalog, we have a specific guide how to use our anchors. It's all included in one table that you can use. For this part of the webinar, I'm going to talk about anchoring solutions. I'm going just to the details of the hold-downs bracket place that Rotoblast offers. And our hold-downs are divided by two main categories. They're like shear and tensile brackets and tensile-only brackets. And these are like NINO and Titan products. And we have WKR and WHTs for resisting tensile loads. All right, for shear and tensile brackets, this shows a comparison table for Titan family. Titan brackets can resist load in tensile, lateral, and shear. And they're ideal for CLT, they're easy to install, and they also have certified values for partial fastening whenever you have intermediate layer, like grouting or something. And it can provide up to 19 kips in shear and 17 kips in tensile. And the height is like there is not too high, and you can integrate it into the floor package. I had this comparison table, which it's not in Imperial. I just want to say that we didn't have this table in Imperial AST values. This is just for the sake of comparison. They're not AST values. So I just want to mention what R sub K means here. It stands for characteristic resistance. And as you see, this is only for comparison that I put this table together here. And what does it really mean is if you have, for example, if you have 100 connections and they're 100 identical connections, they're tested in the lab, this value that you see here means that 95 out of these 100 connections perform better than this. I'm not going through the details of this. If you have questions, we can do it later, but I just want to mention what R sub K means in all these tables. Right, regarding Titan N, it also we provided 2 pairs of holes for connecting to concrete side. Just in case there is a rebar in the concrete here, you can just move the anchor to the other side. All right, regarding Titan S, this the good thing about this product is that we are using screws in bigger diameter screws. It's 0.3 inch diameter screws, and so we have less screws, and you can use the screwdriver, make installation fast, and it allows you to work comfortably on the job site and with a really good high capacities. 19 kips in shear and 17 kips in tensile. And also, as you see, you can do the different patterns if there is intermediate layer exists. With Titan F, as you see, it's ideal for light frame structures. For example, if you want to connect steel floor to the ground, or if you have, again, intermediate layer like concrete grout, you can use the partial pattern. And so you can get shear value around 11.6 kips with Titan F. We also have, okay, this one only shows that you can use Titan N and you get like 2.4 inches um, for any intermediate layer that you need for the job site. And with Titan F, you can get like 1 inch of height adjustability. And we have also Titan V, which has like exceptional tensile and shear strengths. It's also have like different partial fastening capacities, especially, for example, when you don't, for example, with Titan F, you don't have, if the wall thickness is different, you don't have to do a through bolt. You can easily use the angle, the screw, and secure the plate. The other thing is, for example, if you assume this is not CLT, it's just a post, regular post, and you still can get and assume that this layer doesn't exist. You can still get a good capacity. You cannot get a really good capacity with the vertical nails here going directly parallel to grain. You can get a good capacity because of the angled screws here. This was all about our Titan angle brackets. This picture shows a little bit of history of how the Titan family evolved, like the nail lower down, washers added to add like to add to the resistance in the tensile, and also how Titan V was innovated in 2018. But there was a gap between the regular angle bracket and these innovative ones, and that's why the NINO family was born, which also give you a good capacity. For example, like with NINO 100, you can get up to 7.8 kips, and provides values in tension, shear, and lateral. Also, as you see here, for example, for this concrete curb, you have allowance of up to 5 inches for pouring concrete and use it in a partial fastening pattern. And for increasing capacity, you can add washers here. Gives you good axial resistance. This was all about the NINO, and here we move to our tension-only angle brackets. And so tensile brackets, again, we have them for a while. We have had them for a while. What's new in our new catalog is that we try to optimize them to get better values, as you see here. The blue ones are the new ones. Better strength values and like less thicknesses, minimum material. And even like the height has we lowered the height also. And which helps with the like installation. And also they have some different nailing pattern that I will show you in the next slide. And these are like some of their tensile angle brackets. These are WKRs and WHT. And as you see, you can get the height of like up to 14 inches, WKR, and using like different partial patterns. And also for example, for WHT, you can get up to 32 kips of capacity intention. Okay, regarding WKR, if you have a raised wall, you can use partial nailing pattern. And as I mentioned, yeah, the concrete curve maybe up to 14 inches high, you can still use the WKR. This also shows that this product is certified to be installed with GAP. This is one of the applications as you see in the picture. But when you do this, make sure you have to make sure there is using a lock nut at the bottom. So if you just overturn the screw, the bracket doesn't go in the tension before even being used. Um, Regarding our WKR double family, these are really good for prefabrication purposes because they are in two pieces. You can connect this piece uh, in the factory to the wall and connect the bottom piece to the concrete before even the wall is on the job site. And another good thing about this is for the minimum width that you can use WKRs is 1.5 inches, which is makes it like ideal for light frame construction. So picture also shows the prefabricated wall and how it's makes the on-site management very easy. And it also have these slotted holes at the bottom that helps you with the tolerances on the ground side, on the concrete side. For example, if you have a like rebar again here or here, you can just adjust the hole, and then you can install the wall later and connect these two pieces together with nails. And for the WHTs, it's we have it available in different sizes. Again, we have wide pattern and narrow pattern for nailing, and for up to 30 point kips capacity. So these are our plates. You can also use plates for connecting to the ground, and obviously there won't be like it's this one only works in tension. These type of plates, and the WST plates are work in shear. And you can use all kind of anchors that I mentioned, physical or chemical with these. And on the wood side, we're using nail or screws. Regarding our plates, as I mentioned, they can be used in different construction systems. For example, if this is a light frame system, you can leave out the outer holes and use the pattern that is suitable regarding the minimum distances. And this picture also shows that partial nailing available. Also, if there is like intermediate layer of concrete curb, you can just use the nails above that, and there are capacities available for all type of installation. All right, for this part, we're talking about post bases. And we have adjustable post bases, you see here, and fixed post bases. And all of them are suitable for outdoor. And they're all designed for wet service condition, specifically stainless steel and DAG coated that can be used by the sea. In terms of adjustable post bases, we have R10, R20, and R60 family. And these are height adjustable. The height range for R10 and R20 is 5 inch to 13 inches. And for R60 is around 5 inch to 9 inches. And they can resist the load both in shear, compression, and tension. And this variability in height adjustability is helping with just to save the wood from the moisture in the concrete. And again, I just want to say that the values you see in the tables are characteristic values, as I explained before. We also have R40, which is resisting loads in compression only, and it's like you can adjust it from 1.5 inch up to 10 inches. And in the end, we have R70, which is like you can connect this threaded rod to the concrete using chemical anchors. And still height adjustable, can be used for canopies, pergolas. Then we have all these family of fixed post bases. These are T-shaped post bases, and of course they're all concealed these are concealed connectors. These two, let's go through them one by one. Okay, so for F70, as you see here, we have options of the one that is already has drilled holes that can be used with regular dowels, or we have also provide self-drilling dowels, so you can just drill the post base on site. And in terms of the resistances, it can resist tension, compression, shear, and also moment in one side. Then we have extend post bases. As you see in this picture, it can resist moments in both direction. So, for example, for designing a pergola, you don't need to add bracing because of that. And there are two versions for post bases, for extend post bases, one with holes, one without holes. This one is used, the capacity is achieved by using dowels. With this one, as you see in the picture, you're using Z-pox, and these holes are just for Z-pox to get in and create a semi-rigid constraint at the base. And these are the dowels you can use, like a regular dowel or self-drilling dowels with a extend post bases. And we recently published AST values for extend on our website, and this is comes from the testing, modeling, formulations according to NDS and AISC, and it's all the peer-reviewed calculations by third-party engineer. If you go to our website, you can just find a resistance in every direction, moment, and resistance in every direction for X10. We also have another new product for the US market, which is called R1800L. Still, you may not find the datasheet on the website, but if you need more information, you can contact us. It's height adjustable up from around 7 inches to 9 inches, and it's very easy makes it very easy for installation, as you just install the nails on the side. It's also good for wet service condition, and it's like it has Florida building approval. The capacities for R1000L in tension is like up to 2,000 pounds, as you see here. And for compression, up to like 5,260 pounds. Okay, so one more thing about our AT100L is that we provided 4 holes for concrete anchors, just in case the minimum distances on the concrete is not met, you can use internal holes. And finally, I want to talk about our innovative ground connection systems. They developed because of all the challenges, concerns and challenges during installation, and the challenges of connecting timber and concrete. That makes it more efficient for just organizing construction site and like managing tolerances between concrete and timber. One is ALUSTART, the other one is Uplift, and Titan Dive in the end. All right, regarding ALUSTART is a aluminum profile in different sizes for different CLT thicknesses, and which is it's a continuous hold down, and also it elevates the timber, so it's not in direct contact with concrete, and yeah, it gives you capacity in compression, tension, shear, and lateral. As you see, obviously, we have nails for the timber side, and on the concrete side are concrete anchors. And for adjusting the ALUSTART, there are 2 linear jigs and corner jigs. And as I mentioned, the concrete foundation, as you know, it's never level. Tolerances are in centimeters, and but we have smaller tolerances on the CLT side. So there are these adjustment screws that can be used to level the floor. And then there will be formworks on both sides, and they pour concrete to level the floor. And sorry. And then the CLT will sit on top of it. These are different sizes of ALUSTART, ALUSTART 80 up to ALUSTART 175, and which gives you like a thickness between 3 inch to 7 inches of CLT. And as I mentioned before, you can use any kind of mechanical expansion or chemical anchors to connect it to the floor. And then you also can add hold downs if necessary. As you see here, it can, ALUSTART can act as a map. It's like you lay down a layout, and then bring all CLT walls to the job site and install them. That really helps you with the timing. As you see here, they can be cut to every length on the job site. Here's another picture regarding the adjustment and formworks and how they pour concrete. This is the finished one, and then you can take out the bolts after adjustment is done. This is our another product called Uplift, and this is also it's like a post base that you're using for walls. And as you see this in this picture, they use it temporarily um, to repair a damaged wall. Or maybe you want to you want to like put all the CLT walls and then pour the concrete. You can use uplift to carry the weight of the whole building. Both it can be permanent or temporary. And as you see also, it's good. You can do leveling with it. You can add shims to level the wall. And here's our another product called Titan Dive. Um, this is simply a bracket that can be used with corrugated pipes. Um, it basically gives you the maximum freedom during installation and connecting a timber wall to the concrete. And as you see here, there are different ways of installation that you can find the guidelines on our data sheet. And here you see that it can gives you tolerances of angular tolerance of zero, like around 13 degrees. Um, and in the Y and X direction, can give you the allowance for 20 millimeter. And it's basically, you put the corrugated pipes in the concrete, pour the concrete, you put it there, pour the concrete, and then you can install angle brackets later. And so this is a really good product for just reducing alignment errors and allowing each stage of construction to be like managed independently. And yeah, that was for today. And thank you for listening. And if you have any questions, please feel free to contact eng.na@rotoblast.com. And if you have any questions, you can just also put them in the Q&A. Thank you.
Thank you, Nilu. And I just want to thank everybody for attending our webinar today. As always, we do have more webinars coming up throughout this month. If you go on to our Eventbrite where you registered for this one, you can find the next 3 weeks on August 13th, it's timber technology, waterproofing and air tightness of timber buildings. August 20th is wall to window connection, types and solutions for correct design. And then we're closing out August with fall protection systems and solutions for safety by Rothoblast. We look forward to seeing you again soon. Seeing that there's no questions here, I'll just reiterate again, please, if you do have any questions today, tomorrow, next week, or a month from now, feel free to reach out to eng.na@rothoblast.com.